Hello everyone. Here I come with another session of previous question. So in this session I'm going to conclude. I'm going to give the explanation for the TIFER, HCU, and BHU previous questions, which are for last 10 years. Okay. So first question: rank the following molecules with their electrophilicity. So when it is about electrophilicity, it must be carbon center, okay, which is electrophilic carbon. So it will be the electrophilic point here in every molecule. Okay. So as a carbon with more electron deficient, okay, if it is more electron deficient or if it is with low electron density, then it can be more electrophilic in nature. Okay. So it must attach with a minus I group or minus M group, which will decrease the electron density on the carbon and carbon. Okay. So this is what plus I group, it is donating. So this is minus I group, and this is also minus I group. This is also comparatively minus I group. Okay. So here this can act as a plesium with their electron donating in nature, lone pair donating nature. So plesium, and this is also plesium. Okay. So this is also plesium. Okay. So when it is plesium and plesi group, it will decrease the electron deficiency on the carbon, so it will not be much electrophilic in nature. So if it is all are giving plesium effect, among them, if it is minus I, strongly minus I, that will be most electrophilic. Okay, most electrophilic. So chlorine is the highest electronegative atom among this, so it will be most. So 2. Okay. Then among oxygen and sulfur, oxygen will be more electronegative, but the thing is, when it is oxygen and sulfur donating the electron pair, it's going to donate the electron pair more efficiently, okay, when compared to sulfur, because it is 2p system and this is also 2p system, which will result into the conjugation with a long more extent or more parity will be there between the orbitals, so that exchange of the electron density will be easy. So electron density on the carbon comparatively more when compared to this. Okay. So here the deficiency will be more, so it will be more than 4 than the first one. Okay. So option 2, 3, 4, option D is correct. Okay. So this is asked in TIFER 10 years back. So next, arrange the pKa of hydroxy groups of methanol, trifluoroacetic acid, phenol, and benzene. So pKa is inversely proportional to the acidity. So acidity order will be reversed. So highest acidity will be trifluoroacetic acid. Okay. So it will be the least. Then phenol. Then among methanol and benzyl alcohol. So benzyl alcohol is going to give benzyl alkoxide, and methanol is going to give methoxide. So comparatively, acidity of the benzyl alcohol will be less when compared to methanol. Okay. So it will be benzyl alcohol, then methanol. Option A is correct. Okay. Next, acidic strength is greater in what? So generally phenols will be with more acid, which is with minus A group attached. Okay. When it is withdrawing group, it will be more acidic comparatively phenol. Okay. When it is donating group, it will be less acidic compared to phenol. So withdrawing groups are here and here, and these are the donating group. This is without. Okay. So this will be the least, and this is moderate, and these two will be highest. Okay, among these two, okay, among these two, the greater uh, acidic strength will be for orthonitrophenol, because when it is attached to the ortho and para group, it is withdrawing so that it will stabilize the anion. Okay, so among ortho and para, when it is a withdrawing group, it must be short in distance. If the distance is more, inductive effect will decrease of this nitro. Mesomerically, ortho and para are same, but inductively it must be near to the oxide or thin oxide ion so that it gets more stability. So orthonitrophenol will be more acidic. Okay, then paranitrophenol, then phenol, then aminophenol. Okay, next, easy of hydrogenation. So as the resonance energy decreases, as stability of the ring system decreases, hydrogenation easier becomes. Okay, so easiness towards the hydrogenation will be inversely proportional to the stability. Okay, so benzene is having most resonating energy, means it is most stable when compared to naphthalene and anthracene. As the ring number increases, stability decreases. So anthracene is readily hydrogenated when compared to naphthalene and benzene. Okay, so option A is correct. Next, this is a simple question asked in the BHU. So which is nucleophile? Nucleophiles are generally with lone pairs or with negative charge. Lone pair or with negative charge. If it is with empty orbital, it will be considered as electrophile. If it is with octet lesser than the octet configuration, it will be considered to be electrophile. Okay, so this is also electron deficient system, so this is also electrophile. Only NH3, which is with lone pair, can be considered as a nucleophile. Okay, next, so this is a little explanatory question, so read first, so how you understand, we'll see. So what the question is given, like other oxygen containing compounds, N-butyl tertiary butyl ether. So it is a ether. So that is treated with concentrated H2SO4. So what happens when a ether is treated with okay, let's say when a ether treated with concentrated H2SO4, H plus will absorb. Okay, so this will be act as a leaving rate, so that one more H plus will also leave, resulting into the olefin system. Okay, olefin system. So this can be seen in ethyl alcohol. So when it is ethyl alcohol treated with concentrated H2SO4, initially ether will be going to form, and finally ethene will be going to form. Okay. So the same scenario it is given, dissolves in cold H2SO4 concentrated. After that, high volume hydrocarbon material slowly separates out from the solution. So once it is forming an olefin, okay, once it is forming an olefin, is going to polymerize in the same H2SO4. Okay, so that polyethylene is going to form. Okay, so the same is applied here. So let's see what could be the starting material and what could be the product. So the starting material is tertiary butyl, ether, and N-butyl. So this is the starting material. If it gets H plus, so this becomes like this. Okay. If it is broken in this way, it's going to give primary carbocation. If it is broken in this way, it's going to give tertiary carbocation, which is favorable. So once it is forming tertiary carbocation, H plus will be going to eliminate it. So H plus and this is butanol. N butanol already eliminated. H plus, which is from the reagent, okay, or from the catalyst, that's going to eliminate it again. So resulting into what? This olefin, okay. Olefin, if it is polymerized with another olefin, so it is going to give the molecule. So this is going to form a bond to this, so, and this is going to form another bond. So overall, it will be the polymer of this compound. So that is what option C. Okay, CH2, C, CH3, CH3, C. Okay. So polymerization will result into the tertiary butyl polymer. Okay, tertiary butyl polymer. So one of the logically based question based on the olefin formation from the ethers. Okay. Next, arrange the following in the decreasing order of the reactivity towards electrophiles. So to be reactive towards the electrophiles, it should be with more electron density. Okay, it should be with more electron density. So here all are with same two phenyl rings. Okay, but the thing is, this is with ortho diortho substitutions. This is with connectivity. Okay, and this is without any substitutions. Okay. So when a biphenyl system without any connectivity, it will be going to rotate freely. Okay, so that delocalization will be more extensive and the electron density will be more, so that electrophile can attack easily. Okay, so among these three, B will be more electron density, so that because of the extended delocalization. Okay, whereas in C and A, because of the two ortho groups, they will get repulsed. So it will be in perpendicular to each other. One ring will be perpendicular to another ring, resulting what? So if it is also just if these two are phenyl rings, okay. So when ortho di substitution will be there, it will be like this. So these two cannot be at the same angle, so that it will repel. So it will be maximum 90 degrees will be in their angle. Okay. So there is no extended conjugation further. Okay. So it will be perpendicular to each other. Okay. It will be perpendicular to each other. So ring expansion or delocalization, extended delocalization will not be happen. Okay. So because of that reason, the electron density on the rings will be less, so it will be least. Okay, it will be least electrophilic reactive. Okay, whereas in this it is binded one, which also create the repulsion, so that conjugation is a little bit stopped when compared to the free biphenyl system. So B will be the highest, then C, then A. Option C. Okay. So it's based on their structures, and this restricted single bond rotation is called isomerism. Because of the restricted rotation is going to give two different isomers. Okay, two different isomers, they are chiral also, so that kind of isomerism is called isomerism. Okay. Next, one more BHU question which is asked in 2014. So nucleophilic substitution reaction decreasing or easier decreasing. Okay. So when it is nucleophilic substitution reaction, it is asked about the chlorobenzene, nitrochlorobenzene. So 4 chloro, 4 nitrochlorobenzene, and 2,4 dinitrochlorobenzene, and 2,4,6 trinitrophlorobenzene. Okay. So if it is a nucleophilic substitution reaction, this chlorine must be replaced with another nucleophile. Okay. So this is going to happen if it is on the benzene ring. It must happen with the base. So for example, NaNH2 is going to be the reagent. So NH2 minus will abstract the proton. Okay, abstract the proton. So it becomes anion, and this whatever the benzene system will become the benzene intermediate. Okay, benzene intermediate. So before that benzene intermediate formation, there will be anion generation that must be stabilized, that must be supported by the withdrawing group. So the more will be the withdrawing group, the more will be the reactivity of that particular nucleophilic substitution reaction. Okay. So this is the logic here. But because it is happening on the ring, this is going to be the phenomena. But in this, in benzyl chloride, it is not on the phenyl ring, it is outside the phenyl ring. It's going to happen in this way. So once the Cl is eliminated, it will be benzyl carbocation, which is most stable carbocation. Okay, benzyl and propyl are highest stable carbocation. So it's going to form very easily. So whatever the nucleophile, upcoming nucleophile, let's say it is OH minus or any I minus, so it's going to attack. So that's why the benzyl system will be easiest possible in the nucleophilic substitution when compared to all these. Okay, so it will be the best one. Okay, after this, the more the withdrawing group, the more will be the easier formation of anion on the benzene system. So that results into the benzene intermediate, which will convert into chloride. So after benzyl chloride, it will be with more number of withdrawing groups, that is what 3, then 2, then 1. So this is the order. I think it's first one after the okay. So understanding the reaction mechanism is one thing which will decide the reactivity of the molecule. To solve all these kinds of reactions, you must know the mechanism first, and you must know the stability orders, and which is going to stabilize the anions, which is going to stabilize the cations. Okay. So once you know the intermediate that is going to form, then you will be able to apply the electronic displacement. So organic chemistry reactions are basically not confined to one region of the topic. So they are interdisciplinary. Sometimes it may be asked on the reagent stability, sometimes it may be asked on the name of reaction. But whatever may be the condition, you must know these electronic displacements and IUPAC means and types of intermediates and types of reactions. Until unless you are perfect with all these, it will be very difficult to understand and solve the all kinds of organic chemistry problems. Okay. Next, rank the following alcohols in the increasing of acidity. Uh, so it is acidity, which is with anion stability. If it is chlorine, it is a withdrawing group. Okay, there is no mesomeric effect here because it is not conjugated. Okay, so only withdrawing. So it must be near. So among this will be highest. Okay, then meta, then para, then okay, 3, 4. So 3 will be the highest, then 4, then 2, and then 1. Option B. Okay. Next, 2 of the following 4 are more acidic than the methanol. I don't know the acidity of methanol, so how can I do this? It's very simple. You need to find out the most acidic protons having compounds among these. Okay. So find the acidic best of these 4. Find the 2 most acidic compounds. So that will be your answer. So Among this, I can see C as active methylene, which is with two withdrawing group. This will be the highest acidic. Okay. After this if it is carbocation, it's going to stabilize with the mesomeric effect with the lone pair. But if it is carbon ion, once H plus is removed, it will be carbon ion, so it will not affect anything. Okay. Of course, it may be stabilized with the inductive effect. This is also may be stabilized with the inductive effect. But apart from this, this is a mesomerically stabilized, and this is also inductively stabilized, which is strong. When compared to ether group, trifluoromethane group is the strongest withdrawing group. Okay, so compared to oxygen. So C and D are the acidic groups compared to methanol. Next, so this is asked in BHU in 2016. IUPAC name of the following. So if I write, so this is the structure. So this is an ester which is with isopropyl group, but IUPAC name is not isopropyl, it will be methyl ethyl. Okay, so at first position it is methyl. So 1 methyl ethyl, and this is 1, 2, 3, 3 carbons, propionate, which is with what? Fluoro and methyl, 2 methyl, and at position fluorine at second. So it is 1 methyl ethyl, and alphabetically fluorine will come first, 2 fluoro, 2 methyl propionate. So option B. So never iso, tertiary, neo words will not come in IUPAC nomenclature. Remember that. Okay. Next. This is also in BHU 2016. Okay. So same here, 2 questions and 3 questions. Down also same. So think about the chapter, how important it is. Specificities. So when a lone pair is available, it will be Lewis base. So this is available. When a compound is supported by the plus group, it can donate even more. Okay. So this is more compared to this. And this is not having any lone pair because it is positive. So this will not be the Lewis base. So among these three, B will be the highest, then A, then C. Option B. Okay. Next. List of the following compounds decreasing acidity. So withdrawing groups increases the acidity. So find the most withdrawing groups. Fluorine is there. This is also fluorine. This is chlorine. Okay. So for this DNP rule is there. Distance, number, and power. Okay. So first you need to see distance, then you need to see number, then you need to see power. So if distance wise, this is attached to the anion that is going to generate on the same carbon. This is attached to the next carbon. This is also attached to the next carbon. So first you need to see this. So 3 will be the highest acidic. Then withdrawing groups having on the next carbon. So distance is cancelled. Number is same. That is also complete. No power. Power of chlorine will be more. So then this next chlorine next. So 3, 1, 4, 2. That is option C. Okay. Next. The molecule shown below has 4 different types of hydrogen present. Which is most active? So 1, 2, 3, 4 different kinds of hydrogens are given. But the thing is, each will have different kinds of acidity based on the anion stability. Let's make the anions on each carbon. Remove the hydrogen and make the anion. So among all these, I think fourth hydrogen will be more acidic because anion that's going to generate will be in the conjugation, okay, up to the carbonyl level. The other will not have that much conjugation because this is an sp2 carbon. This is also an sp2 carbon. Okay, so there is no conjugation for these two anions. So remove this. Okay, and on carbonyl, it will be carbonyl carbon. It will be positive charge that's going to generate, but not negative. Okay, so that is also not stable. Okay, option 4 is the stable one. Just break down the conjugation. So if it is forming, it's going to be more extensive conjugation. So that will be more stable. Next, another question from BHU 2018. Acidity of the following hydrocarbons. So make it anion. So among these, if I place anion here, it will be more stable. So if I place anion, this will be more stable because this is secondary and this is primary. Primary will be more stable. So if I place anion, this will be diallyl anion. So it will be more stable. If I place anion, it will be more stable because it's going to give aromatic. So among this, highest stable anion will be this one, okay, because it is aromatic. Then diallyl because double conjugation. Then monoallyl this because single conjugation. Okay, this is last because no conjugation. So D, then C, then A, then B. Option. Okay. So that's all BHU questions. So in the next session we're going to see HCU. So there are next 15 questions around. So which will come in the HCU. So we'll discuss in next session. I hope you enjoyed this session.